Good morning, everyone. Now, in this video, we will discuss the fundamental group of the circle. We have defined covering map earlier. Uh, Now we will find out fundamental group of circle by using covering spaces. So firstly, for this, we define lifting. Suppose P is a map from E to B and F is a continuous map of some space X into B. Then what is the lifting of map F? A lifting of F is another map, let us say F curl, from the space X to E such that P circle F curl is equal to F. Or we can say this diagram is commutative diagram. Let us say these are three different spaces E, X and V. Now this is P map which is given to us from E to B. This is F. Again, this is also given map from X to B. Now if we can find a map from X to E such that this triangle is commutative, then we will say that this map F curl, this is the lifting of the map F. Actually, this map lifts the mapping F from X to B to the mapping X to E. Now, whenever P is a covering map, this type of lifting always exists. And this existence of lifting when P is a covering map, this is important tool in studying covering spaces and the fundamental group. So firstly, we will show that covering map for a covering space for a covering space E of B, or for a covering map P from E to B, every path F can be lifted. Then we will prove that as well as path homotopies can be lifted. So firstly, let us take an example of lifting. Let us consider the mapping P from R to S1, which we have proved to be covering map, and this mapping is given by Px is equal to cos of 2 pi x sine of 2 pi x. This we have already proved that this is a covering map. Now we define a path F in the space S1, which is defined by F of S is equal to cos pi s sine pi s. So this is the path in space S1 in the circle, and this path starts at the point B0, which is, let us take 1 0, and this is along the upper half semicircle. So diagrammatically we can say that this path F is basically this. It starts at point 1 0, now this is x-axis, this is y-axis, this point is 1 0, the path starts at 1 0, and as the domain goes from 0 to 1, the path goes from this point 1 0 to the point minus 1 0, because the path is given by f of s is cos pi s sin pi s. So if we can find, now we have this covering map P from R to S1. Let us say this is R real line. We have a mapping P from R to S1, which is our covering map, and we have defined the path. Now let us say this is our closed interval 0 1. Now this is our mapping F, which is our path from 0 1 to S1, which maps along the upper half semicircle. So now we need a mapping from closed interval 0 1 to real line, which makes this triangle commutative. So this required the map will be called lifting map. So what should be this map? Let us say F curl. What should be this map F curl such that this triangle is commutative? So now we know P maps every x of R to cos 2 pi x sin 2 pi x, and F maps every point S in this interval to the point cos pi s sin pi s. So if we define mapping F curl by F curl at S is equal to S by 2 from the interval 0 1 to the whole real line. If we define F curl like this, then we can easily check that P circle F will be, P circle F curl will be F. That is this F curl mapping, which is defined by S goes to S by 2. This is a lifting of the given path F. As we can see, P circle F curl at S, that is P of S by 2. P of S by 2 is cos pi s sin pi s, and F of S, that is also cos pi s sin pi s. So this is the lifting. Now similarly, let us define G to be the path cos pi s minus sin pi s. Now instead of path F, we have taken another path G, which is cos pi s minus sin pi s. Now this G is basically the lower half and semicircle of S1. Now this G starts from this point 1 0 and ends at minus 1 0 along this curve from this to this. This is our G, cos pi s minus sin pi s. Now again we have a covering map P from R to S1, and we have a mapping G from closed interval 0 1 to S1, which maps along this curve from point 1 0 to minus 1 0. Now what should be the lifting G curl, which makes this triangle commutative? So let us define G curl to be minus S by 2. If we define G curl to be minus S by 2, then P circle G curl will be G. It means G curl is the lifting of G. Now similarly, let us take one other example. Now let us take H, another path which is defined by cos 4 pi s sine 4 pi s. Let us define this, which means the path again starting from point 10 and goes along this curve twice and again ending at point 10. Cos 4 pi s sine 4 pi s. This H mapping wraps the whole interval. Now here we have H mapping from closed interval 0, 1 to this circle S1, and this H map wraps the whole interval 0, 1 around the circle twice, because image of 0 is the point 10, then image of 1 by 2, that is also 10. If we put here s is equal to 1 by 2, then it will give cos 2 pi sine 2 pi. So we get this point. Similarly, when we put s is equal to 1, then cos 4 pi sine 4 pi, which is again this point. So this mapping H wraps the closed interval 0, 1 along this circle twice. So now we have to define a mapping H curl from closed interval 0, 1 to R, which makes the triangle commutative. That means this H curl should be lifting of H. What should be the mapping H curl in this case? So if we define H curl by H curl S is equal to 2S. Now this path H curl, this is path in R, which starts at 0 and ends at 2. So now we define here H curl on 0, 1 to real line. So let us say this is point 0 on the real line, this is 1, this is 2. So H curl S is equal to 2S is the map which gives the path from the point 0 to point 2. So this path along this straight line, this is the path given by H curl. And that means this particular path is lifting of H, and this H curl makes this commutative, this triangle commutative. So P circle H curl will be H in this case. So now we can see that if we define F by cos pi s sin pi s, then the lifting map F curl is defined by S goes to S by 2. It means the path F curl, which is lifting of F, that is given by the path starting at point 0 and ending at point 1 by 2, because image of 0 under this F curl, that is 0, and image of 1 is 1 by 2. So this is this path along this straight line from 0 to 1 by 2. Similarly, when we take G, then the lifting G curl is mapped by G curl S is equal to minus S by 2. So if we draw here the path G curl, then that will be this path minus 1 by 2. So that is the path from point 0 to minus 1 by 2 along this straight line in this direction. Similarly, when we take H to be this map cos 4 pi s sin 4 pi s, then the lifting map H curl, that is given by H curl S is equal to 2S, and that is the path starting from 0 and ending at point 2 along again this straight line. So these are some examples such that whenever we have a map P, which is a covering map from uh, E to B, then the paths in space B, they can be lifted to the paths in space E. So here we have taken the paths F, G, H in space S1, and we have found the liftings F curl, G curl, H curl, which come out to be paths in space R. So liftings of paths, they are also paths. So we can say that whenever P is a covering map from E to B, then liftings of paths in space P, they are also liftings in space E.